Good afternoon, sir.
Good afternoon, sir.
Where are we with your batch? 3 years batch, right?
So last lecture we did Fleming's left-hand rule and a couple of problems.
Force on a charged particle due to a magnetic field.
Yes, sir. We had discussed the helix as well.
So where the magnetic field is varying, if we found out X maximum.
Yes.
Right? Where the magnetic field is varying, we found out X maximum. Am I right?
Yes.
Yes.
Okay. Now, when can we place our next doubt lecture?
Sir, we
We
are
have-
scheduled after the college exams are over. We'll take one long doubt lecture to cover all the pending doubts.
Okay, when are your college exams going to be over?
Next month.
Yeah,
25th.
वो भी college exams चल रहे हैं?
Sir, those guys have kept exams every month.
Okay, no, but these exams are what exams are being conducted now? Terminals or half yearly? What is it?
Sir, first term exam.
Okay. So keep me informed accordingly. जिस दिन बोलेंगे उस दिन रात को 9 बजे लगा देंगे, लंबा लेक्चर लेके खत्म कर देंगे. मगर don't lose touch with the topic. You lose touch with the topic, it becomes difficult to get a grip on these topics. It needs continuity. Because magnetism also will start adding up. How will you handle so much pressure here?
So this
is there
week
any
we
way
don't
that
have
we
any
can-
doubt lecture scheduled. So you can keep one this week only.
Yes, on Wednesday.
Wednesday,
What doubts you'll take?
you tell me.
Current electricity booklet, right?
Current electricity booklet, current booklet, exercise 1. Wednesday शाम को time बताओ.
After 6, like all the exams will be over at 6 somewhat, 5:30.
So 6 o'clock.
Can I keep it in the night? Sir. 9 to 12. Sir.
During your college exams इतना लंबा नहीं.
6 to 8.
6 o'clock, 3 years. Wednesday, current electricity booklet, exercise 1.
You can take in the morning.
Pardon?
No, sir, evening.
You can take in the morning.
Morning नहीं एग्जाम होगा ना. मैं मॉर्निंग मेरा क्लास भी होगा.
अच्छा ठीक है.
I'll have classes. Okay. Now listen. Today's class will be one step tougher than what we learned in the previous class. What we learned in the previous class was F is equal to Q into V cross P. As simple as that. We learned the application of this. How to apply force on a charged particle due to a magnetic field. Two very important points in this category. The 2 points were work done by magnetic field on a charged particle is always
0.
all of you, this point is important. Work done by magnetic field on a charged particle is always
0.
always
0.
0. Right? So kinetic energy will remain constant. So kinetic energy will remain constant. Now, we saw it first initially we stuck to the example where theta is 90 degree. What is theta angle between V and B? Then we saw what if theta is not 90 degree. Helical path किया है कि नहीं?
हाँ sir.
Sir.
So helical path, what if theta is not 90 degree? It will go in a helical path. Axis of the helix will be parallel to the magnetic field.
Yes.
Axis of the helix will be parallel to the magnetic field. Now, we solve one typical situation, both electric and magnetic field. Electric and magnetic field. What if you have both electric and magnetic fields? F is Q into E plus V cross B. If I have got both electric and magnetic fields, this force is called, in another word, Lorentz force as well. Lorentz force. Force on a charged particle due to both electric and magnetic fields. Q into E plus Q into V cross B. Appears very simple at the first place. If a charged particle is at rest here, and you have got both electric and magnetic fields along the x-axis, which is the simplest version. Along the x-axis, nothing better than that. This is the simplest possible version. Why? If electric field didn't exist, particle would continue to be at rest. If electric field didn't exist, particle would continue to be at rest. Yes or no?
Yes.
Yes, sir.
Because there is an electric field, it accelerates along x-axis. Force due to magnetic field all throughout is zero. Because even if it accelerates along the x-axis, it is parallel to the magnetic
Yes, sir.
field. Parallel to the magnetic field, sine 0 is 0. And what is the acceleration is equal to capital E small e by n. What is its position after time t? L is equal to half a t square. Nothing special about it, something very simple. Presence of magnetic field will not alter your problem in any way in this particular case. Now, when do you think it will alter? Two situations. One, particle is given a velocity along the perpendicular direction, or magnetic field is along the perpendicular direction. We'll discuss both one after one. Take it down to here.
Done, sir.
So, what is L equal to half a t square?
1 second, say that again.
What do you mean by L is half? The displacement you have written, right? Half a.
Displacement. The distance along the x-axis, or call it x if you have x is equal to half a t square. Distance covered along the x-axis.
Done, sir.
Acceleration is EQ by M, right?
EQ by m. Yeah. This is Q. Make the correction. This is charge of the particle. By mistake, I took charge of an electron.
So, how did you say force into B is 0?
Force due
Zero.
to magnetic field. Charged particle is going parallel to the magnetic field. Angle between them is 0.
Yes.
Sine 0 is 0. Our problem will become slightly complicated if the charged particle is given a velocity of u this. This is y, this is x. I have electric and magnetic fields parallel to x-axis. Charged particle is given a velocity of u along z-axis. Now have a look at this. This is the direction of the electric field and the magnetic field. Particle is given a velocity this. I didn't have the electric field. Particle would have completed a circle and it will come. This is magnetic field. FBI. FBI. Force is upwards. So particle will complete a circular turn this way. Are you able to visualize that?
Yes, sir.
But because of the electric field, it will keep accelerating along the x-axis. It will be a helical path with an increasing pitch.
Yes.
It will be a helical path with an increasing pitch. It will keep going this way with increasing pitch. You give a velocity of u this way. It should technically complete a turn and come back here. But because of the electric field, it is accelerating along the x-axis. Hence, it will be a helical path with increasing pitch. I need to discuss a problem based on this. Can I rub the board?
Yes, sir.
Now look at the information. Particle of charge q and mass m is projected with a velocity v naught, is projected with a velocity v naught j cap in a region where I have got electric and magnetic field along x-axis. E is equal to E naught I cap, B is equal to B naught I cap. Electric field, magnetic field, both of them are along x-axis. Particle is given velocity along y-axis. Find the time after which speed of the particle will be double. Find time after which speed of particle becomes 2v. Can I give you the first hint?
No, sir.
No, sir.
Okay, then wait.
Done, sir.
Done, sir.
Root 3 V naught M by EQ.
Yes, sir.
Yeah,
Yes, sir.
v naught by EQ.
Yes.
So, but wouldn't the magnetic field be acting on the velocity too this time, since the velocity is in the direction of the magnetic field?
Velocity is j cap. Magnetic field is along x.
So the force is along J cap, right, for the magnetic field? No, it's not Z cap. Sorry, sir. Got it. Got it.
K cap.
K cap. Yes.
First of all, the hint is velocity in yz plane remains constant. Speed rather. Speed of the particle in yz plane remains constant. It will increase only along the x-axis. Only electric field does work. Magnetic field in any possible way will not do work. Magnetic field in any possible way will not do work. So initially, if you have given a velocity of v naught along z, v naught square will be vy square along y. You have given the velocity vz square. This is my first equation. Speed of the particle initially was v naught and it was in yz plane. Yz plane, my speed will not change. Speed after time t, speed after time t, you're telling me will be 2v naught. Should be vx square plus vy square plus vz square. Agreed?
Yes, sir.
So I get vx square is how much? 4v naught square minus v naught square. Vx is v naught root 3. If I know Vx, I can write Vx as Ax into T. Capital E, small e by M into T. This is Vx. Capital E, small e by M into T. Q rather. Why am I using E always? Acceleration into time. So this Vx will be V naught root 3 is E cube by M into T. T will be equal to root 3 times mv naught by QE. This is the time after which Vx will be this value. Why are you interested in Vx? If Vx is this value, the resultant speed will be 2v naught. And what makes you say only Vx will change? Electric field is along x-axis. Magnetic field doesn't change the speed of the particle. Vy squared plus Vz squared will remain v naught.
Done, sir.
Now, till here, it was much easier to deal with the circumstances because electric and magnetic fields were parallel. Till here, this was much easier to deal with. Electric and magnetic fields were parallel to each other. What if they are perpendicular to each other? Can I write the board?
Just a second, sir. Done, sir.
You have an electron released from this position. E naught is this way, B naught is minus K. E naught is minus J. Electric field is along negative y-axis, magnetic field is along negative z-axis. You released an electron from the position shown. If you didn't have an electric field here, the electron would keep sleeping at the origin only. Because of the electric field, electron is accelerated in the upward direction. Do you agree with that?
Yes.
FBI. FBI. For a positive charged particle, the force would have been towards the left. For a positive charged particle, force would have been towards the left. Because it's a negative charged particle, it will turn towards the right. Two questions you have to answer at the first stage before I proceed. Are you convinced of the fact that the particle will turn towards the right?
Yes, sir.
If not, apply V cross B with a negative sign minus Q into V cross B. B is upwards, B is inwards, V cross B minus Q into V cross B minus of V cross B का direction. No big deal. But then, if you people observe carefully, I brought the particle to rest here and I am again sending it in the direction. What makes you think it will come to rest on the x-axis again? Listen, initially particle was at,
Rest.
Rest.
if it again comes to rest, net work done on it is,
Zero.
Zero.
it's actually zero here. Magnetic field doesn't do work either way. Electric field, if it is perpendicularly inwards this way, this will be equatorial plane.
Yes.
Yes, sir.
Rather equipotential plane, sorry. Equipotential plane. If it is equipotential, this point and this point will be equipotential. Work done will be zero.
Yes, sir.
Agreed. So when the particle comes from here till here, net work done is zero. So change in kinetic energy should be zero. Initial kinetic energy is zero, final is zero. Once it comes to rest, history repeats and it will again go in that direction. But it's not a semicircle because of the electric field. If electric field didn't exist and you gave a velocity, it would have been a semicircle. This is not a semicircle. If I have drawn it in such a way, it's my mistake. This should not be a semicircle. I am interested in y maximum. I am interested in
Y maximum.
Y maximum.
Y maximum.
y max. That means Vy should become 0. Whole of your game now is for searching for Vy and equating. When is y maximum? When Vy is 0. Now here, turning my hand for FBI alone will not help me. There is another force called electric field. So better play it with mathematics. What is the force on this? Minus E. There will be three negative signs. Please concentrate. E naught minus J cap plus Vx I cap plus Vy J cap cross B naught minus E. Are you convinced with the first step?
Can you please repeat why was the motion in this way?
Motion in?
Why was the motion like this manner, like a parabola is continuous?
First of all, it's not paraboloid, it's cycloid, by the way. First of all, the particle will move up because of the electric field.
Yes, sir.
If it were a positive charged particle, FBI, force would have been towards the left. The particle would have turned this way.
Yes, sir.
But because it is a negative charged particle, I am putting a negative sign in front of the force, it will turn to the right.
Yes, sir.
As it is turning, it comes to rest here. It will
Then why did it come down?
Magnetic field. Force due to magnetic field. Force should always be perpendicular to velocity. Suppose I have a velocity here, force will be this way, so it will keep taking a turn. Magnetic force will always be perpendicular to velocity, no yaar.
Yes, sir.
Draw a tangent to the velocity, har jagah par magnetic force will be perpendicular.
Right.
But why does it come to rest here? Net work done will become 0.
Right.
Change in kinetic energy is 0. Initial is 0, final is 0.
Yes.
And why does work done become 0? Magnetic field either way does 0 work. Electric field will do 0 work on an equipotential surface. You mean to say XZ plane is equipotential? You're right, because electric field is perpendicular to the XZ plane. XZ plane. Electric field is this way, perpendicularly downward. So in this plane,
Yes, sir.
it is equipotential.
And so the direction of I, how did you determine for FBI?
Direction in which velocity?
Right.
FBI, charged particle, whichever direction it is moving, that is I.
Got it.
If not, don't even work on that. F is equal to minus Q into V cross B. It should be in the direction of minus of V cross B. V is in the upward direction, V is inwards. V cross
Right,
B
sir.
ka direction is to the left, negative sign will be to the right. Right? So this is the mathematical equation of Lorentz force. This equation, are you people convinced?
Yes, sir.
keep in your mind the target. What is your target?
Y max.
Y max.
Vy should be
Zero.
so I should find Vy. I should find
Vy.
Vy. Let me simplify this. E naught J cap. E Vx B naught. E Vx B naught. This negative will go. I cross K.
Yep.
E Vy B naught. E Vy B naught. This negative will go. J cross K.
Yes.
E Vy B naught by M I cap. Acceleration along x-axis. Acceleration along y-axis. Already I wrote x-axis. Why do I write I cap? E naught minus E Vx B naught by M.
Yes.
And what's your target?
Vy 0.
Vy. So obviously I'll try to find out Vy from here.
Yes.
Yes.
And I have a trouble. What's your trouble? You will write Ay as dVy by dt.
Yes.
Dt I will bring to the right and I have to integrate. I'll get the answer provided this was a function of time. For me to write Ay as dVy by dt, take dt to the right and integrate. This should be a function of time. Okay, not a function of time. Can I use chain rule here? dVy by dx into dx by dt.
Yes.
Yes.
At least this should have been a function of x. Or I would have tried it with y dVy by dy into dy by dt. At least this should be a function of y. It is neither a function of time, nor a function of x, nor a function of y. अब इंटीग्रेशन कहां से करूं मैं? You get my trouble?
Yeah.
Yes.
So now what they did is, technically my problem would have been over here if the right hand side was a function of time. Now what they did, they differentiated this once again. This is dvx by dt e b naught m vy. Now this, they differentiated d2 vy by dt square is equal to, this will be 0. E b naught by m dvx by dt. dvx by dt I'll substitute from here. I'll be left with d2 vy by dt square minus of e b naught by m whole square into vy.
Yes.
d2 vy by dt square is minus of e b naught by m whole square into vy. They differentiated this once again and brought it into this format intentionally because they know the solution of this second order differential equation.
Yes.
कहीं पर देखा है आपने?
SHM.
SHM. Here omega will be E B naught by n and Vy will be A sin omega t.
Yes.
क्या बोल रहे हो यार? SHM में you used to take the solution of this as A sin omega t plus phi. Initial phase angle you used to take.
Yes.
Here at time t equal to 0, Vy is 0. You released the particle from rest.
Yes.
So at time t equal to 0, Vy is 0. So I put plus phi as 0. Now only one job is left over for me. Omega you know. If you can tell me A, I know Vy, my target. If you can tell me the value of A, I know Vy. How will I tell you the value of A? Differentiate this once again. dVy by dt at t equal to 0. dVy by dt at t equal to 0.
A omega.
will be A omega cos of omega t. This will be 1. Cos omega t will be 1 at t equal to 0. And what is acceleration along y-axis at time t equal to 0? At time t equal to 0, it didn't have any velocity. Only electric field will exert a force. E naught by m. A is equal to E naught by m into omega. Omega is E naught by m. This will be E naught by b.
The lower part is not visible.
I repeat this logic from here, observe this. My whole of the purpose was to calculate Vy. If the right hand side was a function of time or x or y, 1 second. Okay, listen. So in an attempt to calculate Vy, this was neither a function of time, nor a function of x, nor a function of y. So they differentiated this once again, substituted dvx by dt, got it in the format of a second order differential equation whose equation is known to me. That equation, the solution is Vy is equal to a sin omega t. Why didn't you take plus 5? At t equal to 0, Vy is 0 initially. So plus 5 became 0. And I know omega is root over of this, E b naught by m. Tell me the value of a. I will know the complete Vy. How did I tell you the value of a? Differentiated Vy. Once again, put t equal to 0. I get a omega. But that should be equal to the electrostatic acceleration only. Initially, there was no magnetic force. Velocity was 0. Only electrostatic force by m. Simplify that. Substitute this omega value from here. I get E naught by B naught. Are you trying to tell me Vy is E naught by B naught sin of omega t? Yes, this was what you were in search of. At what instant will Vy become 0? Time t equal to 0, pi by omega, so on and so forth. Do you agree with that?
Yes.
I am not interested in 0. I am interested in this instant. This is the second time when Vy will become 0. Put this as dy by dt. This will be E naught by B naught sin of omega t. Dy is E naught by B naught sin omega t dt integral 0 to pi by omega. Can you simplify this? That will be y maximum for us.
Sir. Sir.
Bolo.
Oh, how did you convert it into SHM? That थोड़ा confuse हो रहा है वो.
This is a second order differential equation whose solution is known to us. Whatever I have here, that should be equal to a sin omega t plus 5.
Oh, so how are you saying that?
Pardon?
How are you saying that it will be equal to a sin omega t plus 5?
We know the answer here.
So is there only one solution to that, the SHM one? Can there be another
It
function?
can be cos. Second order differential equation, there can be so many roots. It can be cos.
Okay.
Right? We already know the solution of this second order differential equation. Dy is a sin omega t.
Yes.
You can cross verify. days. Put Vy here, differentiate that twice and put here LHS will be equal to RHS.
Understood, sir.
This is one standard way of solving the problem. Am I expected to remember this final result? Roorkee people gave a question on this for 2 months. I can solve it only if I remember y max. So you have to remember. But 2011, if I am right, one student from Thane, then we used to take VC lectures. One student from Thane proposed an alternate solution. I was very impressed by that solution. Take it down till here, I will tell you what he did.
And so AX and AY, how did you say that equation?
From this, this is the force divided by m. This is j cap, that's I cap.
Right.
That divided by m is acceleration along x-axis. This divided by m is acceleration along y-axis.
Done, sir.
And so over that point, why did it come to rest? Why it did not go in continuous circular motion? वो नहीं समझ
Work done became zero, no yaar. Change in kinetic energy will be zero.
why.
Initial kinetic energy was zero, final will be zero. Work done, you are asking me why it became zero? Magnetic field does either way zero work. Electric field will be doing zero work on an equipotential surface. XZ plane will be equipotential.
Understood, sir.
Done.
So this will be performing SHM.
Vy will perform SHM, not y. Displacement doesn't perform SHM. Vy will increase and decrease as an SHM. In our general equation of SHM, this was d2x by dt square is minus of omega square x. So x displacement was performing SHM. Vy here was zero. Gradually it increases. Somewhere here it will reach a maximum value. Then it becomes zero. Then somewhere here it will reach a maximum value. It becomes zero. So Vy will be performing SHM, maximum to 0 to maximum.
Therefore, the second method, can you give a hint?
We'll do it. For years, I used to think there is no other way of solving this problem. Very confidently, I used to tell the kids also in the lecture, this is the only way you have to do it, deal with it, you have to remember it. When this student came up with this idea, he based his idea on the previous problem. The previous example which I solved, he based his idea on. By the way, what is the value that you got here?
2 B naught by E naught by M.
2 E naught
B naught E naught by B naught M.
by B naught, then I M E B naught square. Am I right?
Yes.
You are supposed to remember this. Roorkee people gave a question on this for 2 marks.
Sir, where you have done A in the left lower part, numerator में भी M होगा ना? Omega is E B naught by M.
Omega is
E B naught by M, right? So sir, in the left lower part, where you wrote A equals to E naught by M. A equals to E naught by M E B naught.
I didn't write A equal to. This acceleration will be equal to A omega, which is equal to E naught by M.
So next line, M will get cut, right? Omega is E B naught by M.
So M cancel हो गया ना यार, E naught by B naught.
Cancel हो गया.
Okay.
Finally M cancel करने से ही E naught by B naught आएगा.
Done, sir.
Now listen to what the kid says. Half M Vx square will be equal to E into Y maximum. If Vy is 0, whole of the speed of the particle is along x-axis. Total kinetic energy is half m Vx square at the topmost point. When Y is maximum, this will be the total kinetic energy. Initial kinetic energy is 0. Final kinetic energy, initial kinetic energy should be equal to work done. Magnetic field doesn't do any work. So your only source is E naught into Y maximum. This force is constant. So force into displacement should be the work done, and that work done is this change in kinetic energy. Do you all agree with that?
Yes, sir.
Vy is 0. So this is the only kinetic energy. Initial kinetic energy should be the net work done. Magnetic field क्यों नहीं लिया भाई साहब आपने जब work done calculate कर रहे हो? क्यों नहीं लिया आपने?
Magnetic field does zero
Field
work.
doesn't do any work.
Magnetic field does 0 work. यहाँ force into displacement without integration डाल दिया आपने. Force constant है भाई साहब. Force constant है तो force into displacement. Right? From this he first calculated Vx square is equal to 2E E naught Y maximum by N. One second. right? Now he used one more fact from this. Now temporarily I'll not write this here. He used one more fact, Ax from the previous equation. We have written Ax, that was dvx by dt. Can you tell me the value of Ax?
E Vy B naught by M.
E b naught by n Vy, right?
Yes.
He used that information. Dvx by dy into dy by dt is equal to E b naught by M into Vy. Obviously, you know why he did this.
Yes.
Yes.
Dvx E b naught by M dy. 0 to y maximum, Vx will be 0 to Vx. When y was 0, what was Vx? Vx was 0. When y is y maximum, Vx was the total speed of the particle. So from
Yes, sir.
here he gets Vx as E b naught by M into y maximum. Why did he calculate Vx from here? He substituted this and this. I calculated Vx in that step and then I rubbed it off because I'll be running short of space, isn't it? Substituting this Vx in this equation, R M Vx square is E b naught by M into y maximum whole square is E naught into y maximum. So far so good.
Yes, sir.
Calculate y maximum from this and see if you're getting the same answer.
Sir,
Bolo,
he took AX from the previous method, right?
previous method say Ax Br.
Okay, thank you, sir.
Yes.
I was very impressed by this approach of it. Net work done is only by electric field. Change in kinetic energy in the final and initial positions.
So can you repeat why you didn't integrate the work done?
Force is constant. E naught is constant. Right?
So the direction is changing of the cross product.
Work done. Dot product. Force dot displacement.
Sorry,
Force
sorry.
is upward. Displacement is upward. Both are in the same direction.
Done. Done, sir.
Sir, how did you took the direction of current?
Who is this guy यार इसमें करंट मुझे ढूंढने से भी नहीं मिल रहा है करंट है कहाँ इसमें
Sir, force, like this, magnetic force, magnetic field.
मैग्नेटिक फील्ड का डायरेक्शन मैंने नहीं लिया भाई साहब इसमें क्वेश्चन में दिया हुआ क्या पूछ रहे हो पहले करंट
Okay,
बोल
sir.
रहे हो फिर मैग्नेटिक फील्ड बोल रहे हो फोर्स ड्यू टू मैग्नेटिक फील्ड विल बी परपेंडिकुलर टू वेलोसिटी भाई साहब 2 मिनट दूंगा टाइम आपको turn the page of the notes go through whole of this properly and tell me if you understood or not.
Yes, sir. Understood.
Done, sir.
Sir, we have to remember Y maximum.
Why maximum? You have to remember because I'll show you the question which J people ask. Roorkee people rather. Do you people have the book HCV with you? Exercise problem number 52. 52. Exercise problem number. On page 234, chapter magnetic field. Chapter magnetic field. I'll give you 2 minutes, please solve. I'm waiting for you.
So question 52 or question 53? 53 matches what we just did.
No, 52.
Find the magnetic field at points PQR.
तुम कुछ और चैप्टर पढ़ रहे हो. Magnetic field chapter open करो. An electron is emitted with negligible speed.
Right, correct. So sorry.
Solve that problem. I'll be back in a minute. I'm keeping you people on mute. 52, 52nd problem. This problem is quite easy, right? All you had to do was Y maximum should be lesser than D. The job done. The electron should not reach the topmost point. If you remember the value of Y maximum, E naught by M B naught square. Am I right? Is it the value of Y maximum? No. M comes in the numerator, E comes in the denominator. 2 should be lesser than D. You get your answer. Find the electric field and hence the potential difference. For 2 marks, the problem is a genuine problem, provided you remember this Y maximum value. Yes or no?
Yes, sir.
Coming to the third part of this chapter. Force on it, current. Till now you dealt with force on a charged particle. You dealt with force on a charged particle. This is force on a current carrying wire. Force on a current carrying wire. Listen carefully to the derivation. You will feel that one negative sign is missing all of a sudden. Please pay attention to it. This is a current carrying wire. If current is in this direction, electrons are moving in which direction? Opposite direction? Yes or no?
Yes.
Yes, sir.
Force is equal to minus E into BD cross B. Force is equal to minus E into VD cross B. Do you agree with this?
Yes, sir.
This is for one electron. How many electrons do you have in that material? NaL. Small n is the number of electrons per unit.
Volume,
Al is volume.
area, and
VD cross B. NEAVD. L क्रॉस B. ये तो चीटिंग कर रहे हो यार. लेंथ को वेक्टर बना दिया. गॉस लॉ में एरिया को वेक्टर बना दिया. अभी लेंथ को वेक्टर बना दिया. करंट इज अ स्केलर. L क्रॉस B. चलो मान भी लिया यार. आपके हिसाब से लेंथ वेक्टर बना दिया. उसका डायरेक्शन तो बता दो. इन द डायरेक्शन ऑफ करंट. L का डायरेक्शन इज इन द डायरेक्शन ऑफ करंट. L का डायरेक्शन इज इन द डायरेक्शन ऑफ करंट. So negative NEAVD is current that you are aware of. NEAVD is current.
Yes.
That you are aware of, right? ये नेगेटिव साइन गायब कहाँ हो गया यार? इस स्टेप में नेगेटिव साइन नहीं लगे. कैरी किया यार.
Direction of VD and L is opposite.
VD and L are in opposite direction. VD is towards the left. L you are
Yes.
taking in the direction of current is towards the right. VD is towards the left. L you are taking in the direction of current. They are in opposite direction. VD and L are in opposite direction. The negative sign is accommodated into that. So you are trying to tell me force hereafter will be I into L cross B on a current carrying wire. You are right. You can either apply L cross B or Fleming's left hand rule FBI. Same thing which we learned on a charged particle. Obviously same thing. force on one charged particle लेकर you took summation of all of them, right? So it will be the same, F B I. Fleming's left hand rule, F B I. Federal Bureau of Investigation. Fleming's left hand rule is applicable. Fleming's left hand rule is applicable. FBI. I into L cross B. I into L cross B. Force on a current carrying wire. There is a paradox which I will address immediately after this. Take it down and pay attention to this paradox. जिसका complete answer I will not be able to give now. I will be able to give the complete answer in the chapter EM.
Done.
So just a second. Done, sir.
So force on a current carrying wire. I into L cross B. Force on a charged particle is Q into V cross B. Force on a charged particle due to both electric and magnetic fields is Q into E plus Q into V cross B. Force on a current carrying wire is how much?
I into L cross.
I into.
L cross.
L cross B.
Now listen carefully. इसका पूरा आंसर I will not be able to give now. I can give in the chapter EM. But till then the paradox you should remember. These are two springs. What are they?
Springs.
This is a current carrying wire which is light. So there is no elongation in the springs. Current carrying wire is?
Light.
So no elongation in the spring.
Yes.
Springs are happy, current carrying wire is happy, battery is happy, we are happy. Yes or no?
Yes.
This happiness will not last long. You switch on a magnetic field perpendicular to the wire as shown. Switch on a magnetic field perpendicular to wire as shown. What is the direction of BIL?
perpendicularly inwards.
So what's the question?
Direction of BIL. I into L cross B का direction
Plus J.
बोलो. BIL.
Upwards, yes, sir.
BI, force is upwards. So springs get compressed when magnetic field is switched on. So far, so good.
Yes.
Yes, sir.
Yes, sir.
That means energy stored in springs will be half kx squared. Work was done by
Sir, magnetic field.
we want you to fall into the trap of saying magnetic field. Magnetic field doesn't do work.
Yes.
Uncharged particle.
Sir, but what else will do work here other than that?
That's a paradox. Battery does the additional work. Temporarily, I gave you the answer. Can you prove it that battery does additional work? I will. First of all, you will have to justify one more thing. You are pushing something underneath the carpet. Force on a charged particle due to magnetic field is zero. Okay. Q into V cross V, force is perpendicular to V. I agree. You are telling me this BIL does zero work. I am not comfortable with it. I am not comfortable with that. BIL and displacement are in the same direction. Neither is BIL zero, nor displacement is zero, nor are they perpendicular, and you are telling me the work done is zero. And the logic you give me is force on a charged particle is zero. Every textbook within the limitations of your syllabus cannot answer this question. It's a strange thing. The concept is very intricate. Temporarily take it down till here. The moment I introduce EMI, I will mathematically prove to you that work done by the battery will be half kx squared. We will calculate and we will show you. Just as in CR circuits, we showed to you heat lost by a resistor exactly matches with half CV squared when we are charging it. Do you remember that?
Yes, sir.
Yes, sir.
Same way, mathematically, we'll calculate and we will show to you that half kx squared was the work done by the battery. Why does battery do work? How does magnetic field cancel out each of this work? Step by step, I'll introduce, not in completely in this chapter, because I need motional EMF for that. And leave 3-4 lines of a space underneath this page, wherever you are writing this.
Done, sir.
So 1 second. Done, sir.
Second point, if it is a closed current carrying loop like this, I and I, you have a magnetic field perpendicular to the board inwards. Net force on it will turn out to be 0. Why? You can see here. Force on this will be this way, force on this will be this way, force on this will be this way.
Sir, this is new one, right?
The next subtopic here.
Okay, thank you, sir.
Force on a closed loop. Force on a closed loop. Force on this is an equilateral triangle. So this force on this will be equal in magnitude, and they form three forces at an angle of 120 degree. Net force, will it be 0 or no?
Yes, sir.
Yes, sir.
Yes. Sir.
Suppose I take a square and I have a current I. Force on this will be this way, on this will be this way, on this will be this way, on this will be this way. Net force turns out to be 0. By the way, net force, why is it turning out to be 0? Because I can arrange these three forces, these four forces as four sides of a closed polygon. Do you agree with that?
Yes, sir.
Yes, sir.
Resultant of n number of forces will be 0 only if you can arrange them as a closed polygon. Here, these three forces will give me 0 because these three forces I can arrange as three sides of a closed triangle. Here, four sides of a closed square. Slowly, you are trying to generalize this. Take a closed loop like this. This is the current carrying wire. You have a magnetic field like this. On every small element I take, force will come perpendicular to this. All such type of forces, integral df is I into closed integral dl cross b. Closed integral dl is 0. Or each of these forces can be rearranged in the form of a closed polygon. Hence, the resultant force will be 0.
Yes.
So you are going to generalize this and say net force. Mind my language, net force on a closed loop in a uniform magnetic field. Both the words are important. If the magnetic field is not the same here, 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 and here, the forces will not be equal. Net force is an important word, and uniform magnetic field. Net force on a closed loop in a uniform magnetic field is always 0. Write down the statement. First of all, take this down and dictate the statement.
Done, sir.
Write down the statement. Net force on a closed loop in a uniform magnetic field. Net force on a closed loop in a uniform magnetic field. is always 0.
Yes.
Now, what kind of questions have they designed on this? They will give you one part of the loop. For example, they give you something like this. This is A and B. You have current in this as I. You have this placed in a uniform magnetic field. They want the force. This length is given as L. They want the force on loop AB. Magnetic field strength is given. Now, by default, force on closed loop is 0. That means force on BA plus force on the loop AB should be 0. AB and BA both put together should be 0. Do you agree with that?
Yes.
Yes.
He is asking force on the loop AB. I can tell you force on BA. Force on BA is BIL plus force on the loop AB should be 0. BIL which direction? You are taking current in the same direction. You are closing the loop. FBI. See the direction of my thumb. F. Forefinger is magnetic field, middle finger is current. F. Forefinger is magnetic field, middle finger is current. So I am getting the force on this to be BIL this way. Force on the loop will be equal and opposite because sum of both should be 0.
Yes. Done.
1 minute. Done, sir.
No. Sometimes this closed loop they will give you this way. They say it is a sine curve. Y is equal to A sine K. K you know is equal to 2 pi by lambda. K is equal to 2 pi by lambda. Right? This is I. This is P2. K is 2 pi by lambda. Now they want the force on P2. Force on sine curve is a requirement. Now what do you say? Force on the sine curve plus force on QP both put together is 0. Right? The closed loop, I am taking closed loop. I take current in QP. Now force on QP will be BIL. What is this length equal to? Wavelength?
Yep.
You Give me the value of the wavelength. And how do I get the direction there? I am taking current in the closing side of the polygon. The current was going this way, this way, this way, and I close the polygon. Only then the net resultant force will be zero. FBI, FBI, B is this way, I is this way, force is in the downward direction. BI lambda, force on the sine curve will be in upward direction equal to BI lambda. Force on the sine curve will be in upward direction equal to BI lambda.
Done.
You insisted that magnetic field should be uniform. If it were non-uniform, force need not be zero. Force need not be
Zero.
Can you show me few examples? Yes, we will. Consider a rectangular loop in the XY plane. This is breadth B, this is length L. P, Q, R, S. P, Q, R, S. Right? Magnetic field is perpendicularly inwards. B naught 1 plus X by V minus theta. B naught into 1 plus X by V. That means magnetic field is perpendicular to the paper inwards. But as you are moving to the right, its value is increasing. Here magnetic field is only B naught, 2 B naught, 3 B naught, so on and so forth. It is increasing as I am moving to the right. Find the force on the rectangular loop. Find net force on PQRS. Current is I. Will you try or should I discuss?
We'll try.
I'm waiting. force on PQ and QR will be equal and opposite. They will cancel out each other. Because the magnetic field is varying the same way along the length. Force on SP is I into L minus J cap cross. L is minus J cap cross. Put X is equal to 0. B naught minus K cap. Are you convinced with this?
Yes, sir.
Yes.
Yes, sir.
Right? I into L. L ka what will be the direction?
Minus I.
In the direction of current, minus J cap. Right? B naught, I put X is equal to 0. All throughout SP, X is equal to 0. B naught IL, J cross K.
I.
J cross. Now there लगता है यार. Now force on QR is I into L. What will be the value of magnetic field along this? X all throughout this is B. B by D is 1. 2 B naught minus K. 2 B naught IL. J
Minus
cross
Minus I.
minus I cap. Resultant of these two is B naught IL minus I cap. Were you very confident that force on PQ and RS will cancel out each other? Yes. But suppose out of academic interest, you want to calculate how much is that value. How much is that value? Consider a small element dx at a distance of x. Why are you bringing in calculus into picture? Magnetic field is varying as I am moving to the right. Magnetic field is varying as I am moving to the right. Force on PQ. How do I calculate? dF is equal to I into L dx I cap cross B naught into 1 plus X by B minus K cap. I into L cross B. L will be in the direction of current. Current is this way. So it is I cap cross this. Do you get the first step?
Yes, sir.
This will be B naught into 1 plus X by B. I dx. I cross K is minus J. With a negative sign is J cap. Least value of X is 0. Maximum value of X is B. B naught I 1 plus X by B into dx J cap. 0 to B. I'm sure you will be able to integrate this further. Same value you will get on RS, but in downward direction. So they both will get cancelled out. So you took the resultant of only these two and gave me the answer.
Done, sir.
Do you people remember current is in the clockwise direction? You have a magnetic field uniform. Net force in the wire is 0. So magnetic field is uniform, closed current carrying load. Find the tension in the ring. Find tension in the ring. We have done this in 4 chapters, right from circular motion. Net force on this ring is 0. Net force is 0. Consider a small element. This is T, this is T. So on every small element, BI, DL, FBI, FBI, FBI. So BIDL is in the outward direction. So net total force on the loop will become 0 because the magnetic field is uniform. Do you agree with that?
Yes.
Now, what will be the tension in the ring? Recollect, consider the small element.
Yes.
We have done this more than once. This will be T, this will be T. This will be d theta by 2, d theta by 2. This will be T sine d theta by 2, T sine d theta by 2, and this will be BI dl. Do you agree with that?
Yes.
FBI, see this, FBI, force will be outwards, FBI, force will be outwards. That is being balanced by what? Tension in the ring. 2T sine d theta by 2 is BI, DL is RD theta.
RT.
2T d theta by 2 is BI, RD theta. T is BIR. The tension in the ring will be BIR. If the current were in opposite direction, then you call it force of compression. Here the ring is getting stretched. There the ring will get compressed.
Done.
if this is a ring of radius r and the distance from the center is d, there is a hypothetical field. Hypothetical radial field. Magnetic field will never be radial. Magnetic field will never be radial. This is a hypothetical radial field. Current is I. Find the force on the loop. Force on loop. Will you try or should I discuss? कोई हाँ तक नहीं बोल रहा है, सो रहे सबके सब.
We'll try.
So that's a radial magnetic field, right?
Radial magnetic field. B naught ER. ER is the unit vector along the radial direction.
Okay, so
If you consider a small element, force on this will be this way. If this angle is theta, this angle will be theta, this will be theta. All df cos theta components will cancel out, all df sin theta components will add up. Observe this ring like this. This is B naught, right? FBI. If magnetic field was upwards, the force would have been radially outwards. Here, force is this way. it will have a component like this. This is theta, this is theta, this is theta. Integral df sin theta is my answer. Integral df sin theta is my answer.
So we have to find tension, right? Integral df cos theta should be the answer.
We didn't ask for tension. We said force on the loop. Force on the loop. See what is written on the board.
Right, okay. And df cos theta.
Df cos theta will get cancelled. Df sin theta is my answer. And sin theta is a constant. Don't integrate that. That integration is quite easy. Integral dl is 2 pi r. This is the 13th exercise problem in HCV. It is in one of the homeworks given to you people. Now, homework by when can you people complete?
It will take some time.
ये बड़ा अजीब खेल है यार. This chapter of magnetic field will be over next class. Magnetic field is split into 2 chapters by HCV. So you will have whole of this exercise in the next class for homework.
Sir, before starting the next chapter, you will take many doubt lectures.
I will have to. या एक लंबा लेक्चर लेके खत्म करना पड़ेगा. कितने चैप्टर्स का डाउट्स पेंडिंग रखोगे वरना?
सर तो सारे डाउट खत्म होने के बाद ही चालू करना.
Okay, as you say. Better. When is the next lecture?
So tomorrow.
So tomorrow for us this unit will be over. Wednesday first we'll take current electricity booklet exercise 1. Based on that Wednesday evening we'll take a call further. Okay.
Yes, sir.
Okay, sir. Thank you.
See you people in the next class.
Thank you, sir.
Okay, bye.
Thank you, sir. Bye, sir.
Thank you.